Hey YouTube, how's it going? Welcome back to part 3 of Leetcode Blind 75. Stick around. Okay, so in this video we're going to be solving the remaining, well, not the remaining questions, the next few questions of Blind 75. The first two videos we covered these three and maximum subarray. If you're interested in any of those, please watch my previous video. But in this video, we're going to be solving the product of an array except self. So over here, let's read through this. It confused me the first time, but it makes complete sense now. So given an array, an integer array nums, return an array answers such that answers that I is equal to the product of elements of nums except nums at index I. So what that really means is that this index here is going to be the product of all of these numbers here. So 2 times 3 times 4 is 24, so we put that here. This number 2 is the product of the rest, so 1 times 3 times 4, which is 12, so we put that here. And 3 at index 3, it's 4 times 2 times 1, which is 8, and then the last one, which is 4 over here, which is 3 times 2 times 1. So one of the tricky things about this is that it says you must write an algorithm that runs in O of n time without using the division operator. O of n time. So now you might think, so the easiest way to probably do this is the double for loop. It takes up a lot of time because you're going to go through, it's going to go and do n to log n to square steps. Sorry, no, big O of n square steps. And then, okay, you're thinking maybe there's another way where you can multiply all the numbers together in the nums array and then make a new array where you divide by the indices. So over here, it's 1 times 2 times 3 times 4, which is 24. And so to get at indice 1, you would have to take 24 divided by 1, which is 24. And over here at indice 2, you'll do 24 divided by 2, which is 12. At indice 3, 24 divided by 3, which is 8. And then finally at indice 4, 24 divided by 4, which is 6. But unfortunately, you can't even do the division operator, which sucks. So there's another way which requires you to sort of see a pattern. Once you see it, it makes more sense. So essentially what happens is if you keep the product starting from the left to the right, like 1 times 2 times 3 times, 1 times 2, 2 times 3, which is 6, and then 6 times 4 is 24, and then you go the other way around. You keep both of these indices, both of those slices together, and you see a pattern. So for the first case over here, let me just write this down. This is what we're inputting. And now starting from the left side product, right? We're gonna start and put 1, and now 1 times 2 is 2. 2 times 3 is 6, and then 6 times 4 is 24 over here. Now if we do the right side product, so over here the right side product, we have we start off with 4. This is going to be tricky because I'm going to be typing the other way around, and 4 times 3 is 12, and then 12 times 2 is 24, and then 24 times 1 is 24 again. So let me spread this out evenly over here. So you, if you notice now, what's strange is that sort of the numbers that we need, or almost all of them, sort of exist in these two arrays. One thing we're going to do is we're going to put a 1 over here in the start of the left and a right side up products. So over here we'll put a 1, and then over here we'll put a 1 as well. And then we can remove this indice over here because this is a length of 5, and this is only a length of 4. And actually the last multiple doesn't really even serve us any purpose really, because this is actually 24 is the product of all of these numbers, but not in nowhere in the output do we require the product of all of the indices. We only need like the first three, so we really truly only need to stop there. So let me remove that, and the same thing with this one over here. So if you don't see it already, what happens is if we multiply at the indices at each of these arrays, we actually get the answer. So over here at index 0 and index 0, if we do 24 times 1, we get 24. Oops, I wrote that wrong. 24. The next one, 1 times 12 is 12. The next one, 4 times 2 is 8. And then finally 6 times 1 is 6. And if you notice here that this is the same answer we have over here, which follows a which runs at an O of n time complexity. So let's code this out. First we need to sort of keep 3 arrays, 1 array which is going to be the left side product, and 1 array for the right side, and finally 1 for the result. So let's do that. Right side product, result, and then we're making an array of integers where length is equal to the nums, and then we're just gonna copy this over. And the reason we're doing that was we're just creating an array of that size, just ready for us to use. Let me make that smaller. Okay, so we got the left, right, and res. One thing is that we always start off with the 1 over here. So for the left side product, we start off with 1, and on the right side product, we start off with 1. So let's do that. The left product at index 0 is equal to 1, and the right side product of 0 is also equal to, sorry, no, the right side at length of nums minus 1. Okay, cool. So now let's start iterating over the array. So this will need to start off at 1 because there's no need to start off there's no need to start off over here, because we need to multiply the next number. So that, and then I is less than or equal, sorry, I is less than length of nums minus 1, and then finally I plus plus. And now we just have to build these two arrays over here. So for the left side, so the left product at indice I, so we can say indice I over here because we're starting off at 1, so which is this one here, and we just need to multiply by this number here to get this one. So 1 times 1 is 1, 1 times 2 is 2, 2 times 3 is a 6. So this is equal to nums at indice 1 I minus 1 times L prod of indice I minus 1. And then for the right product, we will start at, let me write this down over here. J is equal to length of nums, I think minus 1. Is that what we want? Yeah, that's what we want. So in this case, I can just take this. My mouse is a little bit broken. And just replace this over here and this over here. Cool. So now at right side at this product over here, which is 1, also 1 times 4 is going to be 4. So over here we put J, and then nums at J times L prod or R prod at j. This is almost correct. Let me think about this. Oh, I need to make sure this inverses or trickles down. Right now, j doesn't decrement. So what I'm going to do is I'm going to bring this back just so I can keep track of this. And then over here, I say j is equal to length of nums minus I or minus 1, and then minus I over here. Oops. So over here we take j and we don't need this. Okay, so in this case, in the first iteration, it's going to be the last indice, but we want to even go one below that. So that brings us one below that. So we actually need to increment this by 1 and increment this also by 1. And then finally, at the very end, we need to do one more iteration. So range nums is equal to that. And then res at nums I is equal to L prod at indice I times right prod at indice I. And yeah, that is it. So here, let's return res over here. Let's see if this compiles. Let's see, something went out of range with 4. Oh, this is, yeah, the indice is actually over here. I just made one error somewhere. I just got to make sure this is equal to that, so it runs all the way to the very end of each of them. So let's run that. And there we go. So we have it passing. Let's submit this code and see if it passes all test cases. Cool, it is passes all test cases over here. Faster than 41% and is only 5% faster or 5% more memory efficient than most submissions. And that's this one over here. Okay, so we're going to be solving the maximum product subarray question over here. This is similar to the maximum subarray problem, but instead of addition, we are multiplying. So given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. The test cases are generated so that it doesn't go out of bounds. A subarray is in contiguous sequence of arrays. So over here an example is 2, 3, -2, -4. And so now 2 times 3 is 6. And if we continue going, 6 times 2 is 6 times -2 is -12, and then -12 times 4 is -24. So -24 is much lower than, for example, this, which is 3 times 2, which is 6. What's interesting is that if 4 was -4 instead, then the largest contiguous subarray would be the entire array, because a negative times a negative is a positive. And over here, this one's interesting. So all of these numbers are negative except for this one over here, which is 0. So the output is 0, because -2 plus 0 is still -2, and -2 plus -1 is -3. So essentially how we want to address this is we want to track the product going across the array, and we want to keep track of the max. So we'll say var max and product is an integer, and let's make that equal to the first one. So nums and nums at indice 0. I think over here we're sort of, yeah, we're guaranteed that nums is at least 1. So that's good. So now all we have to do is iterate over it, but we will start at 1. We won't start at 0 because we already got the 0 value here. So I is less than length of nums and then I plus plus over here. So now let's keep a track of the product. So the product is equal to nums at index I times the previous product, right? So it's whatever the product is for before that times the number it is now. So for the first case over here, let's say product is num0, which is 2, and then we get an indice 1, which is 3. So 3 times 2 is 6. So now we have to see whether if product is greater than max, right? So we're going to see if product is greater than max. So in the first iteration, it is going to be greater because 6 is greater than 2. So all we have to do is max is equal to 6. Okay. So now finally we have max equal to 6. Sorry, not max equal to 6, max equal to product over here. And then all we have to do is return the max over here. So this is pretty much it, because let's say this resets to 0, because the only way if this is invalid, this can go to negative, positive, negative, and it can still keep track of that. And if it goes to 0, that's good, because that's like a reset, and then it'll start from that a number. But only product will change. Max, we'll still keep track of the max as we go along. So let's run this code over here. Okay, that passes with this test case over here. Let's submit it and see what we get. So the output is, so you know this isn't scripted now because I make mistakes. Okay, so one thing I forgot to account for is that when product goes to 0, let's say it reaches a 0, and product would stay 0, and then anything multiplied by 0 is going to be 0. So over here, for example, if product goes to 0 in this case, well, it still stays 0, so 0 times -1 is 0. But in this case, whenever product reaches 0, we want to reset it actually to 1. So let's make a few changes over here. First of all, this over here, product, we will start off with a default of 1. And over here we will start off with a max of 0. And then finally we're going to also change, well, not finally, we're going to change this to indices 0. So now we're not defaulting some max and products over here at the top to be the first indice. So we start off at 1 instead. There's no harm in that. Okay, and then finally we want to do if product is equal to, let's say if product is equal to 0, then we actually want to reset product to 1. So let's run this code and see whether first it passes the original test cases, which it does, and now let's submit the code and see what we get. So in this case the output is 0, but the expected is 2. Oh, okay, because it's equal to 1. But let's not try to make an edge case for this. I'm curious if this is just the one edge case that doesn't pass. So what I'm going to do is check if length at nums is equal to 1, and if so, just return nums at indices 0, right? That's all we care about. So let's submit this. Okay, see, there's still things wrong, so let's figure this out. So apparently I did this correctly, but not completely. What I need to do is also run the same iteration from the right hand side. At the same time, I'm running it from the left hand side over here. So in this case, I am doing length of nums -1, and while a is greater than or equal to 0 over here, and we need to run the same sort of procedure. We just need to reset product back to 1. So let's run this over here, see what we get. Panic because it exceeded Oh yeah, I'm doing plus, it needs to be minus. Run this code over here. Cool, so let me submit this and see what we get. Cool, we got this submission to pass now. So essentially it was failing on an issue where we had, shit, where did we lose that? Let me see if I can think of it. The only case it wasn't passing was this one over here, where my initial formula, my initial algorithm was doing 3 times -1. Well, first it would do 3 and then realize 3 is the highest. And then it would do 3 times -1, which is 3. But then what would happen is that that would be -3. So -3 times 4 is -12. And 3 in this case is still higher than in -12. What we had to do was also run the formula from the right side left to make sure we covered all the cases. So now over here we would do 4 was the highest and the product, and then 4 times -1 is -4, and then we would have -4, and then -4 times 3 would be -3 as well. And yeah, that's pretty much it for this. This is similar to the problem we did before, kind of similar, not really maybe, but we pretty much went through the array twice on either side. And that's it. I'm gonna stop the video over here for these two questions for blind 75. If you enjoyed this video, show some support in the comment section, drop a like, and I will see you in the next video. Peace.